down to it. When we make a splint in a laboratory, Wolfgang, can you explain what are the steps that we actually take? We are doing exactly the same in digital.
Yeah, well, it follows the same process, making the model. Of course, you've got to articulate the model. You've got to block out the undercuts or create sufficient areas that the splint can hold onto. And then you make the splint. And finally, you make the layer, and then you take it off the model, which is the very last thing, creating the inner fitting surface. So sometimes we don't have retentive undercuts like you can see here. We are kind of void of undercuts. So you probably don't want to fall in the habit of taking your splint halfway up the tooth surface, because we need enough tooth,
Like
cover
this.
enough tooth surface. We've got to grab hold of all the area that we possibly can.
Yeah. Yeah, we'll discover that as we go, I think.
Yeah.
So, all right, so let's get right down to it. So we need to articulate this model. What I've done is we've put it to the center of the workspace with the model designer, but I've tweaked it a little bit just to save some time. So in the articulator, we'll click on the articulator. So there's a few modules we need. We need the model designer, we need the articulator, the splint, and the blockout. All right, so the first thing we're going to do is we're going to articulate the model. So in the articulator, I'll close everything else down so that we can see what's going on. So in the first menu, we're going to select and click name upper, and we're going to do the same thing for the lower. So name lower. And then we're going to import this mounting table. Now, this is, if we work out of the vertex, now PLY images are vertex material. If we click on the texture, we've got the colors that we're using for our splint module. So here we get the opportunity to shift the model to the midline. Whatever I do to the upper happens to the lower as well. The lower is hidden in the background. So basically in this scene, we want to get this model on the table, the mounting table. Similar in a lab situation, we do exactly the same thing. So I'm going to view this from the bottom, and then we've got these, the mounting table has been made transparent gray so that we can see through it. And this gives us the opportunity to move the teeth sort of so that it overlaps. So we can see the premolar and the molar. And we've done this because when we do the wax up module, that the teeth snap sort of in the correct position. So this is heading towards the wax up module. Then I'm going to view it from the right-hand side. I can move it up or down, or with the R key, I can rotate it in this direction. Then we're going to unhide the lower. We can still tweak it a little bit here and there. And then we're going to delete this table. So now we know we've got these models exactly where we want them to be. So now we're going to go into articulation. And we've got this new button. It's called Auto Setup Default Values. So I will press that one just to save time, because this tutorial is not really about the articulator. And I'm going to just click on Auto Setup Values. So you need to make sure that your models are called upper and lower. Otherwise, this is not going to work. Just click on this. This brings in my condyles, and it brings in all the articulated components that I need. So these are the default values that we've used. And I'm going to shut this down, and we're going to go to the articulated constraints. Now, when we're doing the splint, we need to open it up a little bit. So in addition to this, I'm going to open up a new window down here, and I'm going to make this the timeline. And in the timeline, you'll see that this has already been opened. open and close. But with the splint, we need this to stay open, okay? So for this example, I'm going to click on delete all animations. That gets rid of everything and it closes up the mouth and there's just nothing there. I'm going to set this to open, centric, and then what we're going to do is we're going to put in a value in the X rotation field. This could be like usually about 2.5 to 3 millimeters. And how do I know this? Is because I'm looking at the back molar. Now, if this is tiny like this, we're going to end up with a hole in our splint. So I'm going to set this to 3 millimeters. But if you want to make a measure of how thick this is over here, we're going to open up the cutting tools. We're going to select our model and we're going to then click on thickness map. And then with it being selected, we're going to select our dropper and we're going to select this. Now you'll see, okay, we've got different colors. Now we can see on the bottom right-hand side, it says thinnest is 2 millimeters, which is the red zone. So if I want to measure how thick this is, I can set this down. So I can move this down a bit if I want to, and up. So as I'm moving the slider down, 1 millimeter here. So it's about 1.3 millimeters in the thinnest area that's over here. Okay. So I'll exit this way. So this is just a little bit of useful information if you want to do a measurement. We're going to go back, select this object, and we're going to apply this keyframe. Now this opens it up. So if I move this, it opens and closes. Yeah, but I want to keep this at the new location. So I'm going to click on new location. And what that does, it keeps the lower model in position and it deletes all the other animations. So we're back to square one, okay? And now we're going to go through this animation again. So set open. This time we're not opening it up. So I'm going to apply this, set protrusive, and we're going to move this slider down a little bit like this, all right? And then we're going to apply. We're going to set the excursive right side, and we can move the Z slider across. And if you guys want to know, this is all in the videos. So, but if you've got questions, that would be a good time to actually answer a few questions on the articulator. So Wolfgang, maybe you can open a few microphones there.
Yeah, all right.
Okay, are there no questions? It's a good opportunity to ask anything. Okay,
So
nothing?
Michael, the auto button that you pressed earlier on,
Yeah.
that basically brings in the condyles and the opens the bite slightly and sets the articulator at default values. Correct?
Yeah, that's correct. But those default values does not mean that it's good for what you are trying to do at the moment. So, you know, this is why I deleted the animation and started from scratch. But what it does, it saves you a lot of time because the all of these other components have been preset at 33 degrees and 15 degrees, the condyle settings. So all of that's been preset, which is quite good.
Okay.
Okay. So from here, we know this has been articulated. And the next step would be to block out the model, right? So we're going to select our model, go to the blockout module. We'll just click name up again, name upper, and then we're going to create an offset. and this will offset. It'll make a new model, and if I zoom in really fine, this has been offset at 0.2 millimeters. Maybe you can just talk about this quickly, Wolfgang, with the offset.
Yeah, so we want to create an offset model. We call it an engineering fit. It's like engineers would have a nut and a bolt, and there needs to be a small clearance space in there so that the nut can turn onto the bolt. Likewise, in dentistry or any models like that, we need a tiny offset. We want to try and prevent a surface-to-surface friction fit. Of course, if you got teeth like in this example, where we just don't have many undercuts, this is one of the variables that you need to work with. So it's no use setting a really large offset here, because we're trying to get a better grip of the actual splint.
Okay, so we're going to then set this according to your printer requirements. We can't exactly tell you what your best requirements are. You're going to have to try and figure that out yourself. Okay, we're going to apply this, which then makes a new model of this offset model. So we just wait for it. And you may ask what this is about, and this is about remeshing. So everything we're doing with our modules, we keep on remeshing to get a good mesh integrity. If we don't do this, then our Boolean cuts may not want to work and so on. So the voxel size is set at 0.2. You can make it finer if you want to. Don't key in 0.05 or something, because you're going to wait a very long time. But in saying that, when we do crown and bridge work and dies, for example, then we need to offset that about 0.03, which is very, very fine. But we're looking at smaller objects. So the smaller the objects, the finer we need the mesh to be. Okay, so we're going to finish this offset model, and everything else is done with this offset model.
So Michael,
So
the offset model is used for creating the inner fitting surface at the very end.
yeah, that's correct. So this blocked out module gives us three different models, the retentive model, and it gives us a passive model, and it gives us an offset model.
Can you
So if you
open
don't
the,
have,
sorry?
yeah,
Can you
yeah,
open the outliner window to demonstrate the where they are, these models?
yeah, yeah. So we haven't created them yet. We've got an offset model. So the next step in the lab, what we would obviously do, we would survey this. So this gives us a bird's eye view of how we're going to be setting this model for the path of insertion and withdrawal. Now, it's no use doing this, because then the splint is going to stop here, and everything underneath it will be hollow. It'll be an airspace. So we need to when we survey this, we need to make sure that we actually moving this correctly. Yeah. So if I mark these undercuts, for example, and I look at it, you'll notice that all of this in yellow would then be blocked out, or will be an air gap, and we don't want to do this. So what I'm going to do, I can view this from the front so we can see what's going on. And on the x-axis, I can move this down, and we can mark the new undercuts. So you'll notice how it shifts, all of this shifts. So we can set it a bit further and mark these undercuts. Now, Wolfgang, maybe you can just talk a little bit about the undercuts, how that works.
Yeah, well, in the laboratory, we create that survey line, and we want to tuck the splint just under and into an undercut. So here we want to use maximum possible undercut. Sometimes when we make Michigan splints, alone making a splint isn't enough. We need to sometimes incorporate little wire interproximately that can, like an Adam's crib, when we make orthodontic removable appliances, then we would sort of carve away a little bit of the gingiva and try and find an undercuts, because you can't create undercuts. You can sort of survey for undercuts, but we can't make undercuts, but we can look for them by just going under into the interproximal area.
Now, by saying that, Wolfgang, I've seen a lot of splints on the internet. And what these guys are doing is they're doing this, okay? They're doing that, and then they're going like dipping down on the canine, and then they're coming up like this. And I can definitely guarantee you that this is going to be loose in the mouth because you haven't engaged any undercuts, correct?
Yeah.
So ideally, what we should get is we should engage this undercut, and we should get. Oh, it's not painting on my surface. Oh, I can set this to the surface. So ideally, what we want to get is we want to get this, and we want to clip it in to the undercuts at the back. But unfortunately, we don't have much surface, so we are actually ideally wanting to clip it in somehow. So this one is really tricky. So I would probably recommend is to get maximum surface area for a splint like that. You may want to come up a little bit like this. But this is just something to think about. So if your splints are loose in the mouth, it's because you haven't engaged any undercuts. Okay. So if there's any questions related to this, that would be quite good
So, Michael, can
to
you
talk
make a
about.
little divot, like between the teeth, like I said
Yes,
earlier
but
on?
I would probably like a ball clasp.
Yeah,
I would do that right at the end, you know,
yeah,
before we cut out the model, I would
yeah,
say.
yeah, yeah.
Okay. All right. So here we can go through all of that, but I'm going to go through to the auto default models. We can discuss this. If we have time, we can discuss this later. So we're going to click on auto default models, and I may cut out there for a second. I don't know.
If you do,
Do you
that's all
like my
right.
mug, Wolfgang?
Yeah, I like your mug. Have you got one for beer,
Out of
Michael?
my mug, coffee in
Hey,
the morning.
so Michael, there was a question earlier regarding that auto articulator button. And we
Yes,
sometimes set the X value to 1 millimeter, for Bennett side shift.
yes,
So
yes,
will that
yes.
auto button set that as well?
Um, as far as I remember, I have it set that as well. Yes, I
Yeah.
have.
Okay.
But yeah, so it's getting to know the articulator and how it works. And I think we should have a Zoom session only on the articulator, maybe, just to explain in great detail how this works. All right, so we've got 3 different models, and now we recommend our users to delete the models that you don't need. And that's for a reason, because if you've got upper and lower models, so we're looking at 300,000 vertices. This one's 300,000 vertices. So we've got times 3, that's that's 1,000,000 vertices. If you've got an up and a low, that's 2,000,000 vertices. Plus you've got your up and lower model. We're looking at about 2,600, 260,
2 million.
so 2,600,000 vertices, and that's, you're running Blender a little bit. You could run slow, so just bear that in mind. Okay. So choose the model you want, and we want to use this one. So the retentive upper. So if you look at it carefully, we've got the undercuts blocked out. But if you feel that you want to engage everything, then use the offset model. If there's no undercuts, take the offset
Yeah.
model
I
instead.
mean, Michael,
You know,
we're talking about sometimes some of these printable materials are slightly soft, or got a measure of elasticity. So if you are, I mean, if you're working with a very hard acrylic, then you might use the retentive model, but otherwise you could just go and use the offset model where nothing's been blocked out except the offset.
Yeah, that's exactly correct. And maybe we should do that tonight. So what I'll do is I'll take the retentive model and I'll delete that, and I'll take the passive model, which is underneath, and delete that, and we're left with our offset model, and it's 0.2 millimeter or whatever you've set beforehand. And we'll just use this one for now, because they honestly, there's not much retention. Even if you got in front, in the back you don't have any reciprocal retention. So we'll just use this one for now. Okay, it's just something to keep in mind, I guess.
Yeah.
Okay, so this is the next step that we've finished. So when you do Alt H, you unhide everything. All right, so if everything gets unhidden, it could be a bit daunting because you've got so much on the scene. That's all right. We can just hide. And in the Splint module, you just go to the eye icon, and that'll hide the articulator. So as we're doing this, we can see the lower model is still moving, which is good. And we can then do our splint. So we're going to be using the offset model. Always be aware of which models you're working with, which is presented in this box on the left-hand side on the model and on the outliner. At this stage, please don't rename your models. Just stick to exactly what we've got. Otherwise, it's not going to work. Okay, and don't by mistake click the underneath the upper model. So make sure you're actually selecting the model, which we've done with the BlockOut module.
So in this case, Michael, there are two. It's sometimes quite tricky to see that there are two models, two upper models there. I can see it by the fact that there's two names written there.
Yeah, yeah,
Yeah.
and that's a bit my fault, I think, because I could make an update and just hide these original models, so that or at least the upper, that we don't use it. But if you do want to hide a model, you can go to the outliner window and you can just click on this one, and that'll hide the one that's underneath it. Okay.
Just to make sure you select the correct one. Yeah.
Yeah, so just be conscious of what we are actually working with. So I'm going to now name this. In the Splint module, we're working with two models only. We're working with a target model, and we're working with a layer. So those are the only two objects that we are working with. Okay, so so we're going to call this target model. So you will see up here target model. It'll call target model. Shift right click to place our cursor, and then we're going to make a line. Okay, draw the line, and then we can extrude it. And remember how I said that we should keep this to maximum. So no use going up a third on the incisal edge, because when the patient sleeps at night, this thing is going to just pop out when they do anything. So a bit of thought there would go a long way, I think. So we're going to, and this is what we do with the suck down splints as well anyway. So, they very often, they go all the way, the hard soft material we use in the lab. Okay, F to fuse. And we can do this either by doing it this way, or we can paint on the layer if we want to. So for this one, we'll do this method. We'll click on a face that we want to keep, and we're going to click on clean. And so this has been cut out. And in some instances, I've seen some users do it and it doesn't cut out. And that's because you need to try and avoid deep crevices in like interproximal in teeth and so on. Try and avoid those. This is the mesh is very sparse, so it's not a very dense mesh, so it should easily cut through it. And we don't need a dense mesh here because we're using it to create a layer only, and that's it, which is then cut from the fitting surface is cut from a dense model.
Mm.
So here, once we've cut it, we're going to then click on Make Layer. So this gives us a layer, and don't be mistaken, we are not in edit mode. And some people are confused because it lights up in orange. So you can unhide the lines, and you'll notice it's a really rough and horrible looking mesh layer. So by that I mean, if we go into cross-section mode, you can see everything is like doing this. So we've got to deal with this inside, okay? And we're doing this by accepting the layer, but before we get there, this is set to 4 millimeters. And this is because it's been solidified by 4 millimeters. So what it's essentially done, it's 2 millimeters on the outside and 2 millimeters on the inside. So if you wanted to have a layer of 1.5 millimeters, set this to 3 millimeters. Yeah. Or if you want it thicker or thinner, just times it by 2. If you want a 3 millimeter thick layer, then do this 6 millimeters. Okay. So here our default value is 4. Okay. And then we can view this in wire mode so that we can actually see how thick it is. It gives us a visual representation of the layer thickness. Okay. And then we're going to accept this layer. Now we're trying our best to get a good geometry throughout the entire module. We're focusing on the mesh layer. And here what we do is we are prompted with our tooltips to smooth this layer. So I'm going to give it a quick smooth around the border, around the edges. So it doesn't have to be exact, but we'd like to get rid of the intersections that have happened beforehand. Okay, and then we're going to go exit. And what this does, it remeshes it. It gives us a final remesh, and we can set the voxel mesh thickness. So we can set this to finer if you want to, but 0.4 millimeters seems to be quite okay. And then we're going to finish it. So in our cross section, we've got an even layer going throughout.
Yeah. So bear in mind that
Okay.
the inner fitting surface is cut at the very end of this process.
Yeah. Yeah. We have to leave that completely at the end. Okay. So now we're missing material. So we've got a nice 2 millimeter layer. And yeah, I've seen in my dental career, I've made a lot of splints. Just the conventional suck down hard soft material, and some of my clients have used this without any buildup of the occlusal layer, which essentially means that the patient is all they're doing is they're going to be biting on the back. Now I don't know how good that is for the TMJ joint, and I would think it's not a good idea doing that, because ideally we need support all the way through on the lower as well, so that we can equally distribute the forces of occlusion. Isn't that the whole point of having a splint in first place? So all right, so we need to build up this layer. Are there any questions? Maybe Wolfgang, have you got questions, or anybody else?
No, I'll just open up the microphone. So if you guys just want to, got any questions there?
I wanted to ask a small question regarding the BlockOut module. So, do we hear each other?
Yes.
Yeah, great. So the question is following. At the first, we made an offset model, and can you stop on that point with offset model, or you must go through the program that you get from the program, the other retentive or passive model, and then delete it, or can you just stay on the offset model and say, okay, I'm satisfied, I need my offset
Yes,
only?
you can do that. You can just use the offset model, but what it doesn't do, it doesn't throw it into the layer, the collection, which is okay. It's okay. And it's called offset. I think it's called offset model. So those are the two things that are different. It's not in the collection, and it's named something else. But by all means, you can stop there, go to the Splint Designer, and you name a target model, and you can skip all the other stuff that we've been doing.
Yeah, sure.
Absolutely, yeah.
I have one Zwischenfrage,
Yeah,
sozusagen. Yeah.
yeah.
Also, you just said not in the collection, meaning that it will not integrate with the articulator, or what?
No, it's fine. It's fine, because the articulator only uses the upper and the lower model.
Okay, good.
So you can, if you're doing a lower model, for example, a lower splint, you have to parent that to the animation. This is why
Yeah.
we've got link select to
Yes.
animation. So you just say you've got this thing here, for example. You're going to go to the um, blockout module. Then what you're going to do, let me just save this, file save, just in case. Then what we're going to do is, it's already been named lower, that's fine. So we're going to create the offset model, apply, okay? And we're going to finish this. We'll just wait,
And that's it.
finish. And notice that it is in this collection. It says
Yeah,
original model, which is fine. It's okay. It won't interfere with the Splint module at all. Then
yeah,
you go and you just name it target model, and then away you go and start cutting
right.
it. So if you've got flexible material, it's a good idea. You can skip the entire thing. Okay.
Good. Good. Thanks.
Okay. So good question. Thanks. All right. So,
Any other
and of course
question?
you've got to link it to the animation if you're doing a lower. Okay. All right. So let us make a rim. A rim. Um, Again, for the lower, if you're making a lower and you've come this far, you've got to, the target model has to be animated. So you have to click on um, link selected to animation. Otherwise, it's not going to work. You're going to be designing this entire thing, and you may find that you're on frame number 5, and then you can't do this. All right. So I'm going to place my cursor, and we're going to go, well, just close everything else down that we don't get confused. Okay, occlusal rim. And I'm going to click on, make sure it's called layer, which it is. But if you've got an upper and a lower splint, it'll be called layer 1 and layer, and then layer .001. So make sure it's called, the one that you're working with, it needs to be called layer. Okay. So we're going to make the outline, and left click, as we usually do. You can click on this one and then extrude it if you want to, and just carry on.
So,
So where
Michael,
you,
this line, this extrusion, does that happen into vertical direction, up or down?
how do you mean up or down?
Oh, yeah, because with the lower, sometimes you don't see it. So it's pulling into the downwards direction.
Oh, that's when we actually do the rim.
Yeah.
And the reason why I did that is because we don't want to duplicate the entire module for upper and for lower rim. So we can just pull it up,
Yes.
so it extrudes in the Z direction. And instead of redoing the whole model with upper and a lower, we just stick to one menu and just pull it up.
Are there any
Okay.
guidelines as to how you position the line here in relation to the lower teeth? I mean, where's the best place to choose?
Well, like when we do this in the laboratory, for example, I mean, if I set this line down here, you can imagine this is going to go in the Z direction, and we're going to end up with this massive thick block, and the patient's tongue is going to be stopping. So we want to get it sort of where the cervical line of the teeth are more or less. We don't want to go on the palate, for example, because like I said, we're going to end up with a block.
What about in the molar area? Are you
Well,
trying to aim it so that you can get a good occlusion of the lower molars against the actual?
yeah, that's right. So if I look at it from this side, I want to sort of visualize that this block is going up like this and like this. So if this line was like over here, for example, and then it extrudes, I might be halfway on the occlusal surface of the lower molars. And that's exactly the same for if you've got a lower splint, for example, like this, and you want to extrude it. Yeah. If you extrude it if you draw your line and you extrude it like this, then what happens is you're going halfway on the occlusal surface of the front teeth. So in a lower splint, you'd actually have to look at the molars and then draw the line. Do you know what I mean?
Yeah, so the
Draw the line
extrusion
so that
has to take the opposing into consideration.
100%.
Mm.
Yeah, 100%. Yeah. Okay. So I'll just delete this like that. Okay, so now that we've done this, we're going to then click on Make Single Rim. And like we've said earlier on, the lower would come out inside the layer, the green layer. So we would then just pull it up. Now I can view this, say, from the left. I always view this from the right, and orthodontists love viewing it from the left, and I always get confused. So anyway, we can rotate this a little bit if we want to. And we've got to decide, where do we want this to disengage? Now we don't want to do this like this, and this would be ridiculous, because can you imagine having something like this in the mouth? I mean, the patient will be in yawning position for the rest of the night.
So where would you decide, at what stage on the timeline would you do this one?
Um, I would probably say like the early stages, like maybe 1 or 2. Initially, I thought, okay, 3, but 3 is a little bit deep, I found, but I think other users may have found that as well. I don't know. It is transparent yellow, so we can actually see the tips going through the teeth. Yeah. So at the back, you'll notice, because in the back we never have as much space, and this is why I've sort of given it a bit of a rotation like this. Okay, so we can manipulate this. We can bring this forward, we can bring this back, especially with the lower. The lower, sometimes we've got to move forward a little bit, if we want to get contact on the anterior teeth. Yeah.
Mm.
So I would probably say this would be okay, Okay, so we've got it sinking in a little bit, even if it's a little bit less, because we don't want it too deep. All right.
So here's a
So
question. At
yeah.
this stage, can we adjust where the bitrum actually fuses onto the layer? Can we say still change a few of those vertices if need be, or
No,
no?
because if you look at it, if I hide, let's just hide this layer, yeah, and we'll hide the other stuff as well. So what we've got here is we've got, all right, so let's just take the, you see, we've got this going on, you know.
Yeah, all right. So you've got to
Yeah,
make sure initially that you get it more or less correct, the
yeah,
junction.
actually this top should have been closed. I don't know why it's not closed. Oh, okay. I don't know. Maybe it closes afterwards. I forgot my coding. I don't know. So I hope it doesn't fail on me. All right. So from here, we were in this position. I'm going to click on Unify to Layer. Okay. So we just wait for it to unify. Okay, the code worked. Yay! I'm out of the clear. I thought I thought it was meant to be closed, but anyway, it worked. It actually looks like Suzanne, the monkey from
Oh, yeah, how's
Blender.
that? That's
Eh?
interesting.
Eh? Maybe they did that on purpose. I don't know. All right, so this is at 0.5 millimeters, the voxel remesh. We can remesh it a bit finer if you want to, like 0.4. Remember, the finer it is, the more it may struggle with the cutting of the actual, the animation of the lower jaw. Okay, so it's just something to keep in mind. Okay.
So, Michael, the purpose for all of these remesh functions, is that to make sure the Boolean operation will be successful in the end of the day?
Well, not only that, we want it to print nicely. We don't want to end up with a mesh that you put in a printer and then, after all this hard work, it fails and it doesn't print.
Yeah.
So we're trying our best, with all of our modules to get the mesh integrity, especially for crown and bridge work. We need everything, every vertex needs to be in its place. We
Mm.
don't want anything happening because that's disastrous. And I have seen some meshes from other software programs, and I've scratched my head and I thought, wow, this is, I think we're heading down a very good path here. It's a bit of a hassle maybe, but yeah.
So,
Sorry,
just
Wolfgang.
coming back to the interproximal areas to try and gain more retention, is that possible to actually make it like a few divots in there at this stage, or not really? At what stage
Well,
would you do that if you were to do that?
the very end, I would
At the
say,
very
Wolfgang.
end, yeah.
So what I would say is we're going to trim the occlusion, which we're going to do now. We're going to go back
Mm.
into the articulator, and we're following the same steps as in a laboratory. We do exactly the same thing. Every single step is exactly the same thing, because we would put cold cure acrylic over the top to make an occlusal rim, and then we take the articulator and click click click, and we would take carbon paper and all of that stuff to actually get our occlusion. And this is what we're doing here. Thank goodness I don't have to do that anymore. So anyway,
You never
so we
made good splints anyway, Michael.
no
your,
wonder I lost those clients.
your crowns were better.
Okay. Okay. So okay, this is in the articulator. We're going to go to our cutting tools, and we're going to say, okay, this is the object being cut. All right. And then we're going to say, this one is the object making the cut. So it's always a crisscross. That's the object. And it's got like a little dentist drill bit, a handpiece over here. So you can't get confused. So the actual model is becoming the handpiece. I'm not sure how that works, but anyway, it's a sharp model. Okay, so we're going to click on object making the cut. And some users forget about this. And Wolfgang, maybe you can just talk about this offset here. I'll apply it afterwards.
Yeah, so again, the lower model, which is used for cutting, adjusting the occlusion, is offset. So again, we're trying to get away from that surface to surface fit. And also, anything, if this were, say, for example, crown and breech work, having an opposing model which is offset to cut the crown, for example, would make a small clearance space. Often you find zirconia crowns could be a bit high in bite. So actually by offsetting the opposing at this point will create a small clearance. And likewise, we do the same now with the splint. So we're transferring the same technique onto the splint module.
Mm. Even if you, hypothetically speaking, would make a mouth guard and you want the lower jaw to bite into this mouth guard, the upper mouth guard, if you've got surface to surface, it may not engage nicely. But if we've got a little offset there, the lower model would then engage nicely in occlusion onto the mouth guard, wouldn't it not, Wolfgang?
Yeah,
What
that's
do you
right.
think?
That's right.
Yeah. So there's a few ideas behind this whole thing, but some users have forgotten to do it, which is okay because you can still save your splint by using the clean button in the
So,
model designer.
Michael,
Yeah.
can this offset be made quite like a large setting instead of 0.1? Say you want more clearance. Could
Yeah.
you make
Yeah.
it 0.3 or something like that as well?
Yeah. Look, it gives us flexibility as well because Boolean cuts sometimes there can be a situation, and luckily we haven't had many of those, but where the Boolean cut will not work. So you're trying to trim all movements and then all of a sudden you see a hole in it or something. Now that's because the Boolean cut didn't work. Somewhere there was an overlapping vertice. And then all you need to do is go back and then set the offset to 0.11 or 0.09. Just adjust that a little bit, and then you'll find that the Boolean cutting will then work.
So
So
when
that's just a
yeah.
safety thing to fall onto as well.
So when you say go back, you just say press Control Z several times
Yeah,
until you get back to
yeah,
this stage, and then you
yeah.
just change it from 0.1 to say 0.15, and then the Boolean should
Well,
work.
yeah, that's right. But when you do Control Z, don't hit it like, in Microsoft Word or something, like Control Z, and you're going like crazy on the keyboard because all of a sudden you're going to be looking and you don't have a splint left because you're
Oh,
like
okay.
way in the beginning.
Okay,
So
so
just do it slowly.
the code needs some time to run through each backwards operation.
Yeah, yeah.
Okay, I got you.
Okay, so let's apply this. And so this will solidify the model. Now, please don't use honeycomb meshes or anything because it's not going to work. You can honeycomb your mesh at the end. If you want to print a model, just do it at the end. Don't, even with the guide module, don't use, fancy, models or whatever for this procedure. We want to have it simple, just solid models and that's it. Don't try open meshes and all that because it's not going to work. Okay. So here we can do single cut. If we do single cut, it'll apply one cut into it. So for a mouth guard, for example, yeah, you can trim only the right side, or you can trim the protrusive only. And the protrusive only we would use if we would make a splint with an anterior block only, which you can do. You don't have to have one block. You can have two dual blocks on either side. We've got tutorials on that. Or you can just have a front-ended block like an NTI splint or something, and you would then just trim the protrusive and that's it or something. So this gives us flexibility of what we are trimming. Please don't click a button twice, because you're going to then crash Blender, or you're going to be sitting there for half an hour waiting for this thing to come, to cut. A Boolean cut on top of a Boolean cut is disastrous. So only click once. It's a good idea to save your file. So it's a little bit like, if you're going through the woods and you're lost. So you put stones. I think there's a fairy tale about this. So you put stones along the pathway, and then just for a safety mechanism that you can get back to where you started. So we're doing exactly the same thing in Blender. Always just save your file so that you can go back, a step. Okay,
Mm.
so yeah. Okay, so we're going to cut all the movements now. Cut all movements. I may cut out, I don't know.
So, Michael, this is now taking all those animation key points on the timeline into consideration when you're doing this dynamic cut.
Yeah, well, essentially what it's doing, it's taking all those keyframes, and there's 13 cuts. If we go too close, I've tried to do 20 cuts. It takes a long time, and there is a chance of failure. So if we space them like it's a bit less than a millimeter apart, we can successfully do these trimming, which is okay, I think. Yeah. So I mean, if you look closely and hide the lower model, we can see we've trimmed them out pretty well. And when I say that, I just want to demonstrate what I mean by that. So with the articulator, if you want to have a shortcut, go Control X on your keyboard. This will give us the navigation scene of the articulator. So if you work on something like a future, wax up module, and you don't want to go to the articulator module, just put Control X so that you can get the shortcut, and then we can view things from whichever side we want to view it. Now let's just quickly examine this. So if I look at this and go into cross section, I should be able to see how this has been trimmed, which is absolutely perfect. And we're talking about the condylar movements. So let's just get out of here, and I'll bring in the articulator into the scene. So let's have a look and see what is going on actually. So as we're moving, it moves with it. So let's just go back to the articulator and view the protrusive. Yeah. And then view the right side. Yeah. So you can see that this condyle is put, it stays put where it is, and that condyle is moving. And if you measure this, it's 33-degree angle. And as we're moving this down, we will then have exactly the same angle cut in our splint. Okay. So that's the whole idea of this, so that we can get the movement of our condyles into our
So
splint.
this means a working relationship, and the condyle theoretically should be at rest when this happens.
Yeah, I mean, I'm not a TMJ specialist, and maybe some of you guys are, I don't know. but I figured that if you're going with canine guidance, if you're making a splint on canine guidance and this canine is mal-occluded, what's the point? If you're putting 2 millimeters of space between the mal-occluded canine, for example, and the upper jaw or the lower jaw, so you're putting a layer there, you're forcing the TMJ joint into a completely unnatural position.
Mm.
So what we have here is we've got the position according to the movements of the TMJ. So we can't say the digital is exactly what's in the mouth. It's ludicrous to think that. So it'll never be exactly as in the mouth. So maybe a little bit of adjustment would, it could be as well. So
So
anyway,
you could also make just occlusal posterior bite planes with an anterior opening. You've got quite a bit of versatility there in how you design your rims, isn't it?
yeah, we don't have time today to discuss a double splint, which we could do maybe next week or the week after, where we can actually set the jaw into a class 3 or phonetic bite, whichever. I mean, of course, that a phonetic bite you would do in the dental chair. There's quite a lot. There's a bit of a technique to that, but we could set the jaw into the protrusive position, and then you could have your little buttons so that you keep it for a sleep apnea device as well. So there's a lot of flexibility of what we can do with this.
So Michael, if you have a buccal scan of the bite, say you setting that in the chair, do we need the articulator module as such? Except, of course, you need it for the making the occlusal adjustment at the end. But how would you work around that one?
Yeah, we've got a user that does that. They open the bite and then they're using the articulator just to put a few movements into it. But the opening of the bites, they've done that externally out of the digital. But what I've done is I've in one of my videos I've tried to reposition the lower jaw according to this bite outside, done in the surgery. And we are very close, Wolfgang, except that the lower jaw, when it opens up and down, it also protrudes forward a little bit, which is not calculated in the actual articulator, unless we setting when we first start with the opening of the articulator. If we pull that protrusive, this little arrow down a little bit, and then set the lower for, like, permanently set it, then I think we can get quite close with that. But it's still early stages. If we had more data on all of that stuff, we could say, hey, do this and this and this, and then we would be, in a different situation. Yeah.
So that would make a very interesting study, correlating
Absolutely.
the articulator to various bite scans and to measure the accuracy of that. So if there are any university students out there, it's a great project.
Yeah, absolutely. So the last thing that we do is we're cutting the actual fitting surface, and that has to be the last thing. If we want to, we can smooth this down, because if we print it like that, we're going to end up with these ridges. Yeah. So I could suggest smoothing it down, but one of our instructors has actually said to me that, well, when we remesh it, I'll show you what I mean. So if we go smooth, if we had to remesh this and go exit, it already smooths it quite a bit. Yeah. Can you see? It's been smoothed down quite a bit. So you could go along with that if you are in a hurry and then finish the layer, but you can see there's a little bit, so the actual cuts have been smoothed. So I'll just go back.
So, but you still, smoothing it would take that sharp edge off it.
Exactly, yeah, exactly. Because you don't want to hand polish it and so on, you know. I mean, we want to get away from the, you know, the dirty work in the lab and so on, you know, with hand pieces and stuff. So note that this one is set at 0.3, which is quite sharp. You don't want to go on your occlusal surface right now because you're just going to mess it. You're going to mess up all of the hard work that you've put in cutting your splint. So we're just going to give it a bit of a smooth here and there a little bit. And then what I then would recommend is just setting this at 0.05, which is like very, very fine. And you can just give it a once over brush like that. And note now that we've actually changed the mesh structure. So if I go out of sculpt mode on the left-hand side and I go into edit mode, tab, you can see, well, it's not looking too badly. I suppose you could print it like that, but like I've said to you before, we're trying to keep the mesh as good as what we can. So I'm going to exit, and that'll give us a quick remesh structure. And this is set to 0.4, and I've finished the layer. And then finally, we're going to then take the splint tools, the cutting tools. Note now, if you're pressing cut fitting surface, it doesn't do anything. Why? Because we've changed the name. It says object being cut in our articulator. Okay, so click on this one, name layer. We've got our target model, and in the beginning of the tutorial, this preview, I've said we need two objects, the target model and the layer. Okay, this is a layer, this is a target model, a cut fitting surface. We just wait for it to cut, and then we can hide this to expose our fitting surface. And there we go.
Mm-hmm.
Okay, and
Can
it's
you show us the mesh of the final product, Michael?
yeah. So here we've got a nice mesh. The inside adapts from the surface of our model, and the outside. Okay, so and then you just print this. Okay, I think the take-home message is to get the a good fit. Think about surface area. Think about undercuts. How big your offset is. Yeah, and the undercuts is a huge thing as well. Okay. I think yeah, that sort of concludes it. I've gone very deep in depth. We haven't discussed the making of the blockout, how you can sculpt the undercuts. Very important if you've got, you know, maloccluded or overcrowded teeth. You may want to look at sculpting the undercuts. If you've got a diastamer between a premolar and a molar, where the splint has to fit in there, you may want to block that out with the sculpting of our blockout module, where we're sculpting those. Okay.
We'll just invite some questions if you guys have.
Yeah, I might have a question
Yes.
regarding the positioning the rim line.
Yeah.
Is it anyhow possible to put the antagonist model, so the lower jaw, into some kind of transparent mode in order then you could correctly see where are the occlusal surfaces that you can turn the model on the other side and simply see through the...
Yeah, that's a good idea. That's a really good idea. Well, as you know, perhaps transparent is super, super easy. You look for you look for a color field, and these are distributed, throughout our modules. The model designer has it. The Splint module has one over here. You just click Add Color on this tab, for example. I can choose a color, so not delete color, choose a color, and then what I can do is I can go on the alpha value, and set that to 0.5 or something, and then you've got it in transparent.
Great. That's it.
Okay, so
You
it's
said alpha value 0.5 was that?
yes. So the A for alpha, you can set it to whatever you want, or you can use a slider.
Oh, great! I
Okay.
never tried so far. It's a great.
Yeah.
It's
Yeah.
a great
So it's
discovery.
yeah. Yeah.
Super
Okay.
cool.
Yeah. Okay. Good.
So
I think it's
to
just give it some.
export it, you just select the model, the layer, and off you go. Hey?
Yeah. Yeah. That's right. So yeah. So that's basically it. I'll just animate this one more time so we can have a quick view of how this thing actually looks. So in the articulator, we just go. We can set set it to play. We can play the animation, and there we go, left, right, whatever, and
Yeah.
here
If
you
you were
can
to put a
see.
patient name on it, when would you do that? At this stage or before you create the inner fitting surface?
Look, well, can you do the patient name completely? The fitting surface is always the last,
Yeah.
because you don't want to muck around with the mesh. You cannot.
So
That's a lot. Whatever you do on this splint layer, do it. If you want to add things, do it. But yeah.
if you were to make a twin block or exterior attachments or something like that, you'd put those on before you do the final cut, the inner fitting surface.
Yeah, like a sleep apnea device or something.
Yeah, so
Yeah,
you'd put attachments on the buckle surfaces.
you put that first on the buckle surface. Your two buttons. You may have there's a company that has these. It's other way around, actually, I think. So I've actually designed them myself, but I can't share them, unfortunately, because I think they're patented or something, and you put these elastics around like that, to
Which
keep the
is
jaw in a
it's
specific
it's
position.
fairly simple to do. You just would you
Yeah.
make a union of that, or what would you recommend?
Well, no, you don't. You don't really need to unify things.
No.
You can,
You
with
just
these
keep it
3D
as a
printers.
separate object. Look at the layer as its own, and then make the Boolean cut and just put the attachment on as a separate object.
Exactly,
Okay.
exactly. Maybe
Okay.
maybe next week or the weekend off, we can do a sleep apnea device or something. I mean, that would be quite interesting to see with a double dual splint how that actually works.
Yeah. All right. That's good.
Yeah.
Awesome.
Okay.
Well, thanks, Mark. I really appreciate it.
Good. I'm stop sharing my
So
screen so I can see the audience. Oh, jeez, there's so many people.
Great, great. So
Just kidding.
when is the workshop model
50
coming up?
people.
Yeah.
150
Let's see
people.
how many participants is there. Oh, okay. So what is when is the WhatsApp model coming out? How far are you so far?
yeah,
Videos. Videos.
I'm
Videos.
currently probably about halfway through the tutorials. So it's pretty soon now. I mean, the functionality, everything is finished. It's
Yeah,
really the workload's on me now, and I'm sort of
great.
hurrying away to get this thing out. I think it's looking
Beautiful.
really good.
It's a large tutorial.
We
It's a
had a
large
last
module,
minute
actually.
addition, which was the fusion of the gum onto the tooth boundary. And
Yeah.
of course, it is the intermediate between the crown and bridge work and the denture module. So it's essential for having that. It actually does the majority of the work for both of those modules, which is great. But we don't necessarily recommend racing ahead and starting making crowns and zirconia, because we haven't dealt with the integrity of the margin and the blocking of the undercuts for the dies and die spacer and all those other things. But
I mean,
it's,
it is for the model which regards the crowns and bridges. They are more sophisticated in the blocking out perspective, so to say.
yeah, that's right. That's right.
Yeah.
But it does handle the majority of the work of both of those modules. In actual fact, with the teeth and the gum, you can pretty much put that onto a splint layer and away you go. You got your denture, isn't that right, Michael?
Yeah, yeah.
Yeah.
That's
Yeah,
exactly
So
right.
no doubt there will be users out there that will race ahead, and that's okay. You know, with a bit of Blender knowledge, you know, this is we're open book. We're here to teach, and the creativity that's coming from the users is just phenomenal. And
it's
you
great.
know, it's wonderful
Yeah.
to see that. You know what's happening out there. But yeah, just give me another 10 days and we should release it. And no doubt Michael is going to bombard the social media as he goes with
Great.
this is what it can do and that's what it can do. And yeah, so it's got its wow factor there. Yeah.
It's good news.
Yeah, awesome. Yeah, well, I think we'll call it quits. On the Gold Coast, it's 10:15 at night. So you guys are having lunch and breakfast. It's good.
We're going to
It's
sleep.
daytime behind. Yeah.
Yeah. Now I have recorded the session and it is on you. It will be put on YouTube. Actually, all of our Zoom sessions are put onto YouTube. So if you want to go back and just check those out, or you're not sure, or drop us a line, you know, we're here to help. And yeah,
Cool.
it's a learning curve. It's a bit of a learning curve.
Yep.
So
Okay, guys.
Yes.
Do you like my mug? It's cool, eh?
Oh, it's cool.
We're going to be sending out a few to our special users. Eh? It's quite cool. And it's got my name. It's got my name at the sweet.
Michael, I wish you'd have a better coffee machine at home.
Oh, man, I don't put it's actually beer inside here.
All right. That's good.
Okay, guys.
Well, thank you for joining, and hope to see you next time. If you want us to cover something special for our next Wednesday, flick us a message. Good stuff.
Great.
Good.
Bye,
Cheers.
guys. Bye.
Cheers. Wiedersehen.